Everyone, this is Dr. Manali Datta and welcome to my channel Chemistry with Manali. I hope all of you are doing very well. So in the previous video, we have had an elaborate discussion on elements and their electronic configuration. So today we will be taking up another topic, that is valency. But before we begin, I would like to request all of you to post your doubts, clarifications in the comment section. Also, you can let me know on which specific topic you want me to make a video on. I'll specifically take up those topics and also all your doubts in a separate video. So let us come to the topic. So what is valency? Valency is the combining power of an element. Say for example, two elements X and Y are combining to form the molecule XY. So this combining power of X and Y are called their valencies. So you'll understand better with examples. So here the elements from atomic number 1 to 20 are written, their electronic configurations are written, and you can see that three elements, helium, neon and argon, are highlighted in red. So these three elements are called noble gases or stable gases. Why? Because their shells are fully filled. In helium, the first shell, that is the K shell, is fully filled. In neon, both the shells are fully filled. In argon, all the three shells are fully filled. So these three elements are not in need of any electron to undergo reactions. So these three elements will not undergo any reaction. So they are stable, they are inert or stable. And every other element you can see here are not, their shells are not fully filled. So they are in need of electrons to attain stable noble gas configurations. For example, in case of lithium, K shell is filled, but the L shell is not fully filled. So it has a tendency to donate this electron to attain the noble gas configuration of helium. So valency of lithium is 1. In beryllium, beryllium has a tendency to donate this 2 electron and attain the noble gas configuration of helium. So its valency is 2. In boron, it has a tendency to donate this 3 electron and its valency is 3. In carbon, it has a tendency to donate this 4 electron to attain the configuration of either helium or neon. So its valency is 4. Now in case of nitrogen, it has 5 electrons in the L shell. So it has a tendency to either donate these 5 electrons and attain the noble gas configuration of helium, or it can accept 3 electrons and attain the noble gas configuration of neon, right? There are two possibilities here, but the preferred choice is it will accept 3 electrons to attain the noble gas configuration of neon. So in order to accept 3 electrons, its valency will be 3. In case of oxygen also, again it has two possibilities. It can either donate the 6 electrons to attain stable configuration of helium, or it can accept 2 electrons to attain stable configuration of neon. But the preferred choice here is it will accept 2 electrons to attain the nearest noble gas configuration of neon. So valency is 2. In case of fluorine, again there are two choices. It can either donate the 7 electrons to attain noble gas configuration of helium, or it can accept 1 electron to attain the noble gas configuration of neon. But since neon is nearer to fluorine compared to helium, so it will take the second possibility and hence its valency is 1. Similarly, in case of sodium, sodium is nearer to the noble gas neon and argon is far away from sodium. So it has two choices again. Either it can donate this 1 electron to attain the configuration of neon, or it can attain 7 electrons to attain the configuration of this noble gas argon. But since neon is nearer to sodium, so donating 1 electron is a preferred choice. Hence its valency is 1. Similarly, in case of magnesium, there are again two choices. Either it can donate these 2 electrons to attain configuration of neon, or it can accept 6 electrons to attain the configuration of argon. But since neon is nearer to magnesium than argon, so the preferred choice is that it will lose these 2 electrons and attain configuration of neon. So its valency is 2. So this is the logic behind the valencies of the elements. We will have to consider only one point, that every element wants to attain the noble gas configuration of the nearest noble gas and become stable like them. So this is how the valencies are calculated based on the nearest noble gas configuration. Now let us take up few concepts here. How to write the molecular formula of a compound when we know their valencies. For example, the question is, suppose magnesium and chlorine combine to form the compound magnesium chloride. So what will be the formula of the compound? How will we know that? So in the previous discussion we have seen that magnesium has a valency of 2 and chlorine has a valency of 1. So the formula of the compound will be, just write down the symbols of the two elements and the valencies will be written in a crisscross direction. Magnesium's valency will be written here and chlorine valency will be written here. So since it is 1, so we omit this and the formula of the compound is MgCl2. Let us take up another example. The question is, for example, aluminium and oxygen, they combine together to form a compound. Now what will be the formula of the compound? Now let us first try to find out what are the valencies of aluminium and oxygen. So aluminium atomic number is 13. So electronic configuration will be 283. Oxygen atomic number is 8. Electronic configuration will be 2.6. Now aluminium has a tendency to lose these 3 electrons and attain the noble gas configuration of neon. So aluminium valency is 3 and oxygen will have a tendency to accept 2 electrons and attain the noble gas configuration of neon. So its valency is 2. Now just write down the symbols of the two elements sidewise and put the valencies in a crisscross direction. So aluminium valency will be written near oxygen and oxygen valency will be written near aluminium. So this is the molecular formula of the compound that will be formed by the reaction between aluminium and oxygen. Now let us take up the third example. Carbon and oxygen combine together to form a compound. Now what will be the molecular formula of the compound? So carbon atomic number is 6. So electronic configuration will be 2.4. Oxygen atomic number is 8. Electronic configuration will be 2.6. Now carbon either can lose these 4 electrons or it can accept 4 electrons to attain the nearest noble gas configuration. So its valency is 4 and oxygen's valency is 2. Now just write the symbols of the two elements side by side and put the valencies in a crisscross direction. So the valency of 4 will be written next to oxygen and this oxygen's valency of 2 will be written next to carbon. Now let us reduce it to the lowest value, C2O4, it can be written as CO2. So this is the formula of the compound that will be formed between carbon and oxygen. So this is how valency and electronic configuration can be used to predict the molecular formula of the compounds. So from here onwards we will jump on to the next higher topic, that how reactions take place. So to understand the next concepts better, we will try to have a better understanding of the electronic configuration and valencies. So please try to practice or take up questions on these two topics and you can also post your doubts in the comment section. So thank you everyone. Please keep an eye on the channel. I'll be posting videos regularly. Thank you everyone. Also requesting you to like and share my video and subscribe to my channel. Thank you everyone.